In this podcast, we're going to talk about scientific notation, which is useful for making big goofy numbers like this, 120 million, look like this, 1.2 times 10 to the 8th. And then also to expand numbers like 1.2 times 10 to the 8th into big goofy numbers like 120 million. Alright, let's begin. Let's start with 483. It's not a big goofy number, but it's a good place to start. 483 can be assumed to have a decimal at the end of it. When we put a number in a scientific notation form, we want to put the decimal after just one digit. So we're going to move the decimal 1, 2 places. So our new number is 4.83. However, 4.83 and 483 do not mean the same thing. They're two different numbers. And we're trying to rewrite 483 just in a different form. And so if we were to make 483 out of 4.83, we would multiply it by 100. But we can take this one step further. We can condense it one more time. We take 4.83 and we multiply it by 10 to the second. 4.83 times 10 to the second equals 483. Notice that we maintained the same amount of precision as we were given in the initial number. And here's our final number. Here's our answer. Also, there's the number 2 in the exponent. And notice the pattern that we moved the decimal 1, 2 places. And so therefore we have a 2 in the exponent after the 10. Alright, let's move along. Here we're working with a very small number that's goofy. And we're going to put it into scientific notation form so it's easier to read. This time though, we're going to be moving the decimal to the right. We want just one digit before the decimal. So we're going to put it right here. That means that we're going to move our decimal 1, 2, 3, 4, 5, 6, 7 times. But because it's going to the right, it's going to be a -7 in the exponent. So this number is going to be written 2.3 times 10 to the -7th. Okay. Okay, in this number, 80 million, we know that the decimal is at the end of the number, but we want to maintain the precision that's demonstrated in this number. So we're going to write not 8.0 times 10 to the 1, 2, 3, 4, 5, 6, 7, because that's giving more precision than we wanted to. Instead, we're just going to write 8 times 10 to the 7th. Alright, now let's move on to expanding from scientific notation. Now we're going to expand out of scientific notation form. We have 3.001 times 10 to the 5th. First thing you should notice is that the exponent is positive. That means that we're going to be expanding into a greater number, or to a large number. If we had 3.001 times 10 to the -5th, we would be expanding into a very small number. But that's not what we're doing. So 3.001 times 10 to the 5th means that we're going to be moving our decimal 1, 2, 3, 4, 5 places. We fill zeros in, and we have 300,100 as our new number. In this number, we have a couple of different things going on. We have a -4 as the exponent and a negative sign in front of the constant. The negative sign in front of the constant, or the 7, is not a big deal. We're just going to simply move it to the front of the number. Because we have a negative number in the exponent up here, we're going to move the decimal 1, 2, 3, 4 places to the left. If we fill in zeros in those places, we come up with the number 0.00076, and we're just going to put that negative sign in front. And there you have it, negative 0.00076. Alright, let's do this last number, just for practice. Once again, we have a negative in front of the constant, and this time we have a positive number in the exponent. So 9 times 10 to the 5th, or 9 times 10 to the 1, 2, 3, 4, 5. Even though there was no decimal there, we assume that there's one there. And we want to keep the same precision, so we're going to write this number as 9, 1, 2, 3, 4, 5. Because we had 1, 2, 3, 4, 5 zeros. Because we moved the decimal 5 places. And there you have it. That's scientific notation. Use this to finish the rest of the worksheet and come to class with questions tomorrow.